Sometimes unit tests aren't enough. Your unit tests and focused integration tests make sure that your JavaScript code works. But what makes sure your HTML loads that JavaScript correctly? How do you know everything fits together end to end and really works when a user visits your site? Hi everyone, my name is James Shore and this is Let's Code Test-Driven JavaScript. I'm here with my lessons learned about smoke testing front-end code with PhantomJS. In this episode, we're going to look at how you can use PhantomJS to test your code end-to-end. We'll start with a brief overview of when and where to use smoke tests, then look at how PhantomJS works. Next, we'll set up PhantomJS to run from an automated build, then examine two different ways of writing smoke tests for a simple application. All the examples in this episode come with source code, and you can find it at the link on your screen. As we discussed in Lessons Learned number 4, smoke tests are part of your overall strategy for testing your code. That strategy includes unit tests for testing that you've written your JavaScript correctly, focused integration tests to make sure you're integrating with other processes correctly, and a little bit of end-to-end integration tests to make sure everything fits together well. That's where smoke tests come in. They're not comprehensive, they just make sure everything's wired together correctly. For example, the code we're using in this episode consists of a server component and a browser component. Now we've got really good unit tests on both the client and server sides, but they only test that the JavaScript manipulates the DOM and that the server code loads and serves files. It doesn't check that the HTML loads the correct JavaScript or initializes that JavaScript correctly. It doesn't test that the server starts up or that it's serving the correct files to the browser. That's where smoke tests come in. Now do check out Lessons Learned number 4. We go through smoke testing in more detail and we talk all about how to do smoke testing of the server. Now in this episode, we're going to look at the client. And in order to do that, we're going to need some way to simulate the browser. That's where PhantomJS comes in. PhantomJS is a headless WebKit. It's a self-contained browser with no UI that you can program using JavaScript. Now it's using WebKit under the covers. That's the same engine that powers Safari, but it's not the same thing as running Safari directly. So running PhantomJS isn't as good as running a real browser, but it is good enough for smoke testing as long as you have good cross-browser unit tests, such as we have in the live channel, where we're using Karma to do really extensive unit testing on real browsers like Safari and iOS and Chrome and Firefox and IE and so forth. As long as you're doing that, PhantomJS is great for smoke testing. It's not a real browser, but it's close enough to not matter. Now to use PhantomJS, you're going to write some JavaScript code to control it. It looks kind of like Node.js code, but it isn't Node.js. What it's doing is it's using something called the CommonJS module specification, which is why it has that require line in it. But it's important to remember that the code that you run in PhantomJS is not the same as the code you run using Node.js. It's not going to have access to your Node modules or anything like that. When you run PhantomJS, by running PhantomJS and then the name of the code you want to run, PhantomJS is going to start up a process, which is then in turn going to launch WebKit. Then it will load your code. When you run your code, the first thing you're going to do is require web page. That's a module that ships with PhantomJS. Again, it's not coming out of your Node modules because this isn't Node.js code. When you require web page and then create that page, what you're effectively doing is creating a tab in the WebKit browser that you can load any URL into. Next, you'll typically want to redirect the console so that anything that's output to the console inside of the browser shows up on your actual command line. And that's what we do here. And then we open a page. That will tell WebKit to actually load the URL that you provide, and then it will call the callback with a success parameter. If that variable is equal to success, you know you succeeded. The next thing we've got here is a page.evaluate, and it looks like a callback just like anything else, but this is not actually a callback. What page.evaluate says is to take this snippet of JavaScript and ship it over to the browser. And this is an important distinction to make because since this code is running in the browser, it's not actually running in the PhantomJS process. So any variables you've defined in the rest of your PhantomJS code won't be accessible to this WebKit code you've just shipped over. And similarly, any variables you define here, even global variables, won't be accessible to PhantomJS. All you can do is return a value. So PhantomJS is going to run this code. It's going to console.log, which will come back to here and run the console log function we've defined here. That outputs to our console, to our command line window, and then we're done. Then the very last thing we do with PhantomJS, you always have to be sure to call phantom.exit, otherwise your code will hang. So that is a very simple bit of PhantomJS code. There's three things I want you to particularly notice here. First, PhantomJS code is not node code, even though it looks a lot like it. Second, PhantomJS code controls a WebKit browser. And third, you can send functions over to that WebKit browser using the page.evaluate function. But remember, those functions aren't running in PhantomJS and it doesn't share variables. There's two ways to get PhantomJS. You can either download it from phantomjs.org, which is kind of straightforward, or you can install it as an NPM module, which is handy if you want to have some way of automatically updating or delivering this to other people. However, if you do install the PhantomJS module, which is how I prefer to do it, do be careful. As far as I can tell, this node module is maintained by a third party. It does lag a bit behind the official PhantomJS releases, and sometimes, a little too often, unfortunately, that installer has bugs. In particular, as I record this, the current version of the NPM module is 1.9.1-1, which is PhantomJS version 1.9.1 and the -1 version of the installer. That actually has a defect in it that prevents the installer from working at all. So if you're watching this now and that's still the current version, then be sure to use this second command here on the screen to install version 1.9.1-0, which I've confirmed does work. Now, once you've got PhantomJS installed, you need to run it automatically. I've chosen to tie it into my existing test infrastructure. You, of course, can run it in any way, and the code I'm going to show you here, it will apply in those cases as well. Now, the way this is going to work is we're going to run Jake. That's going to launch Node, which will run our Jake file, which will run Node unit. For details about how this works, check out Lessons Learned number 2, where we cover it in detail. And then we run smoke test. So Node unit is going to run an additional test I'm writing just to run PhantomJS, which is called smoke test. And this is what's actually going to launch PhantomJS. The way this works is first it needs to launch the server. PhantomJS needs to download the files from somewhere. So we launch the server, and then we launch PhantomJS. The way that process launching works is we use childprocess.spawn. For details on that, check out Lessons Learned number 4. We cover it in a lot of detail there. When we launch PhantomJS, when we run the PhantomJS process, we're going to give it a file to run, and that's where our smoke test actually lives. That smoke test is going to be run inside of PhantomJS, and that's going to tell the WebKit browser embedded in PhantomJS to load our server URL. Now let's look at the code. All right, here's our smoke test code. Again, I've chosen to tie this into my existing Node unit infrastructure, which means that it runs just like any other test. It has a setup, a teardown, and then the test itself. Setup and teardown are starting and stopping the server. That's covered in Lessons Learned number 4, so I'm going to just gloss over that piece. And then the test is what's doing the magic. This is what actually runs PhantomJS. The way this works is we spawn a child process that runs Node with the PhantomJS installer's start script, that's this here, and that's actually going to run the PhantomJS binary, and then passing in the name of the PhantomJS script we want to run. This is where our actual smoke test lives. And then finally, we tell it to inherit standard I/O, which just means that anything that PhantomJS outputs will show up on our console. Next, we monitor for that process to exit. When it does, we'll get an error code, and we assert that that error code is 0, because if it isn't 0, we had some test failures. And then finally, we're done, and that goes to teardown and stops the server. So there's 3 things I want you to notice here. We're starting the server, starting PhantomJS, and then checking the exit code. And of course, when we're done, we stop the server. Now that we've got PhantomJS running, we can actually write our smoke test. The app we're testing here is the same simple application we've used in other examples. We've got a simple form with an example field and a submit link. And when the submit link is clicked, we're going to check the field to see if it's empty. If it's empty, we're going to turn it pink. The way we're going to test that in a smoke test is by clicking the submit link and checking that the invalid class appears in the example field. Now again, this is not a comprehensive test. A smoke test doesn't need to be comprehensive. It's just exercising one usage scenario. But in so doing, we're making sure that all kinds of things are being done correctly. We're making sure that the server is running and giving us the correct HTML and JavaScript. And we're making sure that the HTML includes the JavaScript and runs it. and that the HTML and JavaScript are using the same IDs. So if we look at our HTML, what we're testing here that we're not testing anywhere else is we're making sure that this script line is set correctly and that this initialization code is working. And that's an important function of our smoke test, is to make sure that that's connected up with the rest of the code. Everything else has unit tests, but this piece doesn't. This test itself is fairly straightforward. We're just clicking a link and checking the class, but we do have a choice of how we click that link. One option is to simply create events in the browser, and that is my preferred choice. It's simple, it's easy, and you can reuse existing unit test abstractions. However, because it's creating the events in the browser, it isn't 100% real. So our second option is to send events from PhantomJS itself. That's going to create OS level events just like a real user and send them over to the WebKit browser. However, it's low level and fiddly, and for that reason, I don't particularly like it. As long as we're doing good unit testing in the rest of our code and we verified those unit tests manually, then I don't think we need to use option number 2. But I have included examples of both of those approaches, and you can decide for yourself which is best for you. Let's take a look at the code now. Here's our PhantomJS code. This is the code that's actually running inside of PhantomJS. First thing we do is we're just going to create a constant that points to our server URL. And then we're going to open a tab, create a tab, and we're going to redirect the console as I showed earlier. And then we're going to open that server URL. So we're going to visit the server and see what happens. We'll get a success callback. If that does not equal success here, then that means that the URL couldn't be loaded for some reason, and so will error out in that case. The actual test running happens here. In this case, we've got 2 tests running, but typically you'll only have a few. Now, if you do have a lot of tests or you have a more complex test infrastructure, you might want to use another tool called PhantomJS. I'm not demonstrating that here, but it has more sophisticated test support. And it's something that you might want to consider for yourself. It wasn't appropriate for WeWikiPaint in the live channel, and for this lessons learned, I wanted to show just the bare bones basics of PhantomJS. But if you have a lot of form testing to do or something like that, check out PhantomJS. So what this is going to do is it's going to run our tests, and the tests return a value if they failed. And so we'll check that. If that was okay, we'll run the next test. If either one of those failed, then we'll die and exit with an error code. Otherwise, we'll exit with 0. And remember, that's going to communicate back to our smoke test, which is going to check that exit code and determine whether or not to fail the test. And of course, we've got a good exception handling throughout. Now let's look at our 2 test approaches. The first one we have is to just do everything in the browser. This is just like any other DOM test. This runs entirely in WebKit, so it looks just like a DOM unit test. What we're going to do is get the text field element, get the submit link element, and then we'll click the submit link here. And then we'll check the text field CSS class. We'll look at the class name, compare it to the expected value, and if they aren't equal, we'll return an error. If they are equal, everything's fine, and we'll return null, which for this example, for this test, means everything was fine. And again, good exception handling. We return an error if we caught any exceptions. If you have an exception occur inside of your evaluated code, the code that runs inside of WebKit, PhantomJS will not do anything with that exception by default. You do have to catch the exception and return a value. Remember, the only way the JavaScript that runs in WebKit can communicate with PhantomJS is through this return value here. Anything you return from within here is returned from page.evaluate. So that's option 1. Let's look at option 2, which is to have PhantomJS generate your events. You can see that this is a lot more complicated because PhantomJS can't click any particular button. It can just click coordinates. You have to tell PhantomJS to click a particular coordinate on the screen, which means what we have to do is find out where the submit link is located. And that's what we're doing here. We're running some JavaScript code in the browser to find the location of that submit link. We're getting the submit link element, we're getting its bounding rectangle, and we're calculating where it's located on the screen here. And then we return that into the location variable. Next, we click that link. So we send the click event to that precise location, which will cause it to be clicked, and then we check the CSS class just exactly the same way we did before. We run some code inside of WebKit to get the text field, get the class name, compare it to the expected value, and return an error if it didn't work out. To summarize, smoke tests are a type of end-to-end integration test. They're not comprehensive, they just make sure everything's wired together correctly, and they're best when you have an existing comprehensive suite of unit tests and focused integration tests. PhantomJS is a programmable browser that's great for smoke testing. You write JavaScript to control WebKit, and then you can also pass JavaScript into WebKit to run inside that browser. To run PhantomJS in our build, we write a test that starts the server, runs PhantomJS, and then checks the error code that PhantomJS returns. And in the PhantomJS test itself, we can either run in browser or send events, and I recommend doing the former. So that's what I've learned so far about front-end smoke testing with PhantomJS. Thanks for watching, and I'll see you next time.